Hey, want to see something cool? How about we start with something really weird? What if I told you that particles can be in two places at once, or that simply observing something changes it? This is not science fiction, it's quantum mechanics. Welcome to my channel. And today we'll take a journey into the heart of quantum mechanics, where tiny particles follow rules that are completely alien to human intuition. If you think you know how the universe works, get ready to have your mind blown, because this is quantum physics. Now, you may be asking yourself, what is quantum mechanics? Well, quantum mechanics is the study of the behavior of matter and energy at the atomic and subatomic level. Where classical physics fails, quantum takes over. But trust me, quantum is not some obscure theory known only to mad scientists. In fact, many everyday things like MRIs and lasers rely on quantum mechanics. Let's delve deeper into the history of quantum mechanics. It all started with Max Planck in 1900. He proposed that energy comes in packets, or quanta, which was a radical idea at the time. Then, in 1905, Einstein built on this idea to explain the photoelectric effect, showing that light can act as particles called photons. This discovery earned him the Nobel Prize in Physics in 1921. As the 20th century progressed, quantum mechanics grew rapidly. Scientists like Bohr, Schrödinger, Heisenberg, and Dirac created a new way of thinking about the universe. Today, it's one of the most successful scientific theories ever developed. So now that we know what it is and where it came from, let's jump right into the strangeness of quantum mechanics. First up, we have wave-particle duality. Yes, you heard that right. Electrons and photons can behave like both particles and waves. Think about that for a second. A particle is something like a marble or a tennis ball. It has a definite position and momentum. A wave is something like a ripple in a pond or a sound wave. It has a wavelength and frequency. Now imagine trying to describe a sound wave with a wavelength and frequency using properties like position and momentum. It just doesn't make sense. To understand this concept, let's look at the famous double-slit experiment. When electrons are fired one at a time through two slits, they create an interference pattern on the screen behind the slits, just like waves. This shows that electrons have wave-like properties. But here's where it gets weird. If you try to observe the electrons as they pass through the slits, their wave-like behavior disappears. They act more like particles. So, what does this mean? It means that reality is not what we see but what we choose to observe. Or does it? Next up, we have superposition. This is the idea that a particle can be in all possible states at the same time until it is measured. For example, an electron can spin up and down at the same time, until we measure it, at which point it will collapse into one state or the other. This is a very controversial topic in quantum mechanics. Many scientists believe that this collapse is caused by observation, while others argue that it is a purely mathematical concept. Either way, it's clear that this is one of the strangest concepts in quantum mechanics. Let's illustrate this with another famous thought experiment, Schrödinger's cat. Imagine a cat in a box with a device that has a 50% chance of releasing a poison. According to quantum mechanics, the cat is both alive and dead until we open the box and observe it. Once we do, however, the wave function collapses and the cat is either alive or dead. Some people find this thought experiment disturbing, but it's really just a way to understand the strangeness of quantum mechanics. Next up, we have the observer effect. This is the idea that measuring something affects its behavior. We already saw this in the double-slit experiment, but it's important to remember that this isn't just a quirk of quantum mechanics. It's a fundamental part of the theory. Without the observer effect, quantum mechanics wouldn't work. In fact, the observer effect is so important that some physicists believe that reality does not exist unless we look at it. That's right. Reality is created by observation. Here's another example. Let's say you want to measure the position of a particle. To do this, you need to interact with the particle, otherwise you can't know where it is. But the act of interacting with the particle changes its momentum. This is called the uncertainty principle. Next up, we have quantum entanglement. This is often referred to as spooky action at a distance by Einstein. Entanglement occurs when two or more particles become linked together. Even if they're separated by light years, when you affect one particle, the other is affected instantaneously. But how can this be possible? How can information travel faster than light? Well, it can. Thanks to quantum entanglement, this phenomenon has been observed many times, and it's one of the most exciting areas of research in quantum mechanics. Now that we've covered some of the weirdest concepts in quantum mechanics, let's talk about some real-life applications. First up, we have quantum computing. Quantum computers use qubits instead of bits like traditional computers. Qubits can be in a superposition of states, which allows them to perform calculations much faster than traditional computers. Another application is quantum cryptography. Quantum cryptography allows for the creation of unbreakable codes. This is because any attempt to measure a quantum system will affect its state. Now let's move on to mind-blowing implications. First, reality is probabilistic, not deterministic. This means that we can't know exactly what will happen in the future, only the likelihood of certain outcomes. Second, observation plays a fundamental role in shaping the universe. This idea has led to many philosophical debates about the nature of reality and the role of consciousness in the universe. Could our thoughts actually influence quantum systems? Maybe. Now let's talk about modern frontiers. Quantum teleportation, time crystals, and multiverse theories are just a few of the areas that scientists are exploring. Who knows what we'll discover next? Now that we've covered the basics of quantum mechanics, it's time to wrap things up. We've learned that the universe operates according to strange and sometimes counterintuitive laws. But don't worry, you don't need to be a physicist to understand these concepts. With a little imagination and curiosity, anyone can grasp the basics of quantum mechanics. So, what does this all mean for us? Quantum mechanics tells us that reality is more mysterious than we thought. The universe doesn't always behave the way we expect it to, and there's a lot that we don't know. But that's not a bad thing. In fact, it's exciting. It means there's still so much to discover, so much to learn. So keep your mind open, keep asking questions, and who knows what you might discover. You never know. You might be the next Einstein, Bohr, or Schrödinger. You'll be part of the next quantum leap in our understanding of the universe. If you enjoyed this video, please like and share it with your friends. And if you want to continue learning about quantum mechanics, check out the links in the description. Thanks for watching, and I'll see you next time. But before we go, let's leave you with one last thought. Everything you touch, see, even your own thoughts, they all follow the rules of a quantum world. You're not just in the universe, you're made of the mystery itself. Now, here's the big question. Do we create reality just by observing it? What do you think? Let us know in the comments.